Okay, so today we're going to be talking about percent composition, and this lesson correlates to Chapter 10, Section 3 in your book. So percent composition is defined as the percent by mass of each element in a compound. So your compound has a total mass, and then we look at what mass of that compound comes from each individual element, and we turn that into a percentage. All right, so you can see a couple of the graphs down here at the bottom, a pie chart kind of explaining to you what what percent composition looks like. All right, so to calculate percent composition, the first thing we're going to do is to calculate the molar mass of our compound. That's something that you should all know how to do. That's from Section 1 in this chapter. All right, so then you're going to divide the mass of each element, however many elements there are, by the molar mass of that compound, all right, which you found in number 1, and then multiply by 100. The sum of all those percents for each individual element should be close to 100. Sometimes it won't be exactly 100, but it should be pretty close. All right, so let's calculate the percent composition of magnesium chloride. So in order to calculate percent composition, we need to have a formula. So we need to figure out the formula of magnesium chloride. So we have Mg and Cl. Magnesium is a metal, and therefore this is an ionic compound. So magnesium has a charge of 2+, chlorine 1-, and after we cross the charges, we should end up with a formula of MgCl2. So we're going to find the molar mass of MgCl2. All right, so Mg, we have 1 atom times the molar mass of magnesium, which is 24.3, so that gives us 24.3. And then for chlorine, there's 2 atoms times molar mass of 35.5, which gives us 71.0. We add those together for the total molar mass, and we should have 95.3 grams as the molar mass for magnesium chloride. So in order to find the percent composition of each element, we need to take the mass of that element divided by the total molar mass. All right, and we've already found those masses right here. Okay, so for magnesium, we take the mass of magnesium, which is 24.3 grams, divided by the total molar mass, which is 95.3 grams, multiply by 100, and you should get 25.5% of this compound is magnesium. All right, and then we can do the same thing for chlorine. So we take the mass of chlorine, which is right here, so 71.0 grams, over the total molar mass, which is 95.3 grams, multiply by 100, and we get 74.5% chlorine. And if we add those two together, you can see that we would get exactly 100%. Okay? All right, so you can actually use those percent compositions to find the amount of an element that can be obtained from the given amount of a compound. Okay, so we've already determined that magnesium chloride is 25.5% magnesium and 74.5% chlorine. All right, so if we have 25 grams of magnesium chloride, if we take that 25.0 grams and multiply by that percentage as a decimal, okay, so as a decimal, 25.5% is 0.255, we would get the amount of magnesium in that 25 grams, and that is going to be 6.37 grams of magnesium. And then we can do the same thing for chlorine. All right. The other way you could do it, instead of doing that multiplication, is you could just subtract. All right, so we know that there's a total of 25.0 grams, so if we subtract the amount that is magnesium, all right, we would get the amount of chlorine, which is 18.6 grams of chlorine. Okay? So, we can also calculate percent composition from mass data instead of using a formula. All right, so the data that we've obtained is that we have 18.35 grams of a compound containing lithium and sulfur. All right, and when that's decomposed, 12.81 grams of sulfur is obtained. Okay, so we have a total of 18.35 grams of a compound, all right, that has lithium and sulfur. All right, we know that the mass of sulfur is, I can't write, a little dyslexic there, is 12.81 grams. So if we wanted to find the mass of lithium, all we would have to do is subtract these two, and we would get the mass of lithium, which in this case is, if I can do some math in my head, 5.54, I believe. Okay, so now we have the total mass of the compound, and we have the mass of each element. So we can do our percent composition calculation. So for sulfur, I'll do 12.81 grams over the total, which is 18.35 grams, times 100, and that comes out to 69.8%. I think my sig figs are off there, but that's okay. We'll let it slide this time. All right, so then in order to do lithium, you would do the same thing. So 5.54 grams over 18.35 grams times 100, and that comes out to 30.2% lithium, sulfur. And you can see that if you add those together, you get a total of 100%. All right, so on your own, tonight or tomorrow morning or whenever it is, you need to complete pages 326 to 327, numbers 33 through 36.